Right now, as you and I speak, something is happening in our solar system that should be impossible. Not unlikely, not improbable, impossible. An object from another star system, the interstellar traveler we call 3I Atlas, is changing itself. And when I say changing, I don't mean glowing brighter or shedding dust like a comet brushing past the sun. I mean it's physically transforming, growing larger, doubling in apparent size as if it were alive or engineered. Between October 12th and 19th, 2025, something extraordinary unfolded in the quiet darkness beyond Mars. Telescopes across the world from Chile to Hawaii watched a 23-kilometer-wide object suddenly expand to 46 kilometers. Not over centuries, not even over months, but in just 7 days. That's like watching Mount Everest wake up, stretch, and become 2 Everests tall, right before your eyes. NASA confirmed the numbers. The European Southern Observatory confirmed them again. And yet none of it made sense. Because what we were seeing shouldn't happen. Not under gravity. Not under thermodynamics. Not under any physical law that's ever governed the universe. Natural objects don't grow in the vacuum of space. They erode. They sublimate. They disintegrate. But this visitor from the stars, defied that rule. If it were simply a cloud of gas expanding, the light signature would tell us so. But it didn't. Its albedo, the reflectivity of its surface, suggested something solid, something structured, something deliberate. And that's when every scientist watching realized we were standing at a threshold moment. Because in all of recorded astronomy, nothing like this has ever been observed before. Now, as a physicist, I've spent decades studying the motion of galaxies, the birth of stars, and the dance of gravity that binds it all together. I've seen anomalies, I've seen surprises, but never something that rewrote the rulebook so boldly. So what exactly are we witnessing out there in the deep? A comet that refuses to behave like a comet? A structure unfolding in the void? Or the first evidence that we are not the only engineers navigating the stars? Whatever the answer is, the truth behind 3I Atlas, it's big. Bigger than science fiction, bigger than anything humanity has ever seen. And to understand just how far this discovery reaches, we have to start with what we thought we knew. The simple, predictable behavior of comets before 3I Atlas broke every law we trusted. Because once you see how the universe is supposed to work, you'll understand just how terrifying it is when it suddenly stops following the rules. For as long as we've watched the heavens, comets have been our faithful messengers. They move with predictability, grace, and a kind of cosmic honesty. They are ancient time capsules, dirty snowballs made of ice, dust, and frozen gas left over from the dawn of our solar system. When they approach the sun, they wake up. Solar radiation heats them. Their icy shells begin to vaporize, and they form the glowing tails that streak across our skies, tails that always point away from the sun, pushed by the solar wind. We know their orbits. We know their composition. We can even predict when one will crack apart, like comet Shoemaker-Levy 9, which was torn into fragments before slamming into Jupiter in 1994. That's how nature behaves, predictably, under the laws of physics. But then came 3I Atlas. From the first moment it entered our telescopes, it was already wrong. Its trajectory didn't match anything gravitationally bound to our solar system. Its speed, over 60 kilometers per second, was far too high for a local comet. This wasn't one of ours. It came from somewhere else. Astronomers labeled it Interstellar, making it only the third confirmed object of its kind, after ʻOumuamua and 2I Borisov. But even among those rare visitors, 3I Atlas refused to fit the mold. When ʻOumuamua zipped past us in 2017, it puzzled scientists with its cigar shape and unexplained acceleration. When 2I Borisov appeared in 2019, it looked just like a comet should, a normal one, just born in another system. But 3I Atlas, it changed size. It grew. Comets don't grow, they shrink. They fragment, they die. And yet, as it neared the inner edge of the solar system, telescopes detected a doubling of its cross-section, a geometric expansion that wasn't an illusion or a dust plume. Something about its structure was unfolding. Imagine watching a comet suddenly unfurl like a flower in space. Not in vapor, but in symmetry. Every panel, every ridge reflecting sunlight at new angles as if designed to do so. The data didn't whisper this, it screamed it. For scientists, it was the equivalent of hearing your heartbeat change rhythm and realizing it's not yours anymore. And this is where our collective certainty began to crack. Because if comets don't do this, then whatever 3I Atlas is, it isn't a comet. Not in the natural sense. Not in the sense that physics textbooks for centuries have told us they should be. So if nature didn't build it, then who or what did? It began quietly. No alarms, no breaking news, just a subtle anomaly buried in the streams of data flowing from observatories across Earth. For a week, the skywatchers noticed something strange. Not in brightness, not in color, but in geometry. Every night, as 3I Atlas moved through the constellation of Perseus, its light curve, the way its brightness fluctuated, behaved as if the object were breathing. Its reflection shifted in patterns too precise to be random, too mechanical to be natural. At first, astronomers thought it was an error, maybe a calibration issue, but as more telescopes turned toward it, from Mauna Kea, Pan-STARRS, and SS Gaia mission, the pattern held. Every major observatory confirmed the same finding. The object's apparent cross-section had doubled over 7 days. Now in astronomy, doubling is not a word we use lightly. Stars evolve over billions of years. Planets shift orbits over eons. Even comets crumble over months. But this thing, it changed in real time. Think about that for a moment. An interstellar visitor, millions of kilometers away, physically altering its structure in the span of a single week. NASA analysts compared the datasets 3 times before releasing their preliminary report. They couldn't deny it anymore. The shape of 3I Atlas was in flux. Something or someone had triggered a transformation. And then came the radar signatures. The Goldstone Deep Space Network in California picked up reflective patterns, inconsistent with dust or gas. They weren't scattering signals like debris, they were reflecting them like plates. As one analyst later put it, we weren't looking at a cloud, we were looking at a surface. That single observation changed everything. What had begun as a faint, icy traveler now looked more like architecture. And as NASA prepared to run new models, one paradox in the data shattered even their most conservative theories. Here's the problem. When something doubles in size, we expect its mass to increase proportionally, unless it's made of vapor or expanding gas. But 3I Atlas didn't lose mass. It gained it. According to gravitational analysis from NASA's JPL, the object's total mass, inferred from its orbital perturbations, had increased by nearly 20% over that same week. That's impossible under known physics. Nothing in space simply creates mass out of nowhere. Stars fuse hydrogen to form heavier elements. Black holes draw matter inward from their surroundings. Comets sublimate, releasing gas and dust. They lose material. But 3I Atlas was manufacturing mass. It's as if it had pulled invisible matter from the vacuum itself, as though it were feeding on the very fabric of space-time. Some speculated it might be interacting with dark matter, a substance that makes up roughly 85% of the universe's mass but doesn't emit or absorb light. Could 3I Atlas be using dark matter as fuel? No one could prove it, but the math didn't reject it either. Others whispered something more radical, that it might be self-assembling, harvesting stray particles and cosmic dust, reconfiguring its geometry like an adaptive organism or an intelligent probe repairing itself between the stars. And just when the scientific community began debating whether this could even be natural, a new series of observations deepened the mystery. Because 3I Atlas didn't just gain mass, it changed its density, selectively, intelligently. Parts of it grew heavier while others became almost hollow, as if it were redistributing internal material for a purpose. This wasn't random. It was behavior. And as the reports stacked up, one question echoed through mission control. If 3I Atlas is breaking our laws of physics, whose laws is it following instead? But the real shock, the moment that sent the world's space agencies into total silence, came next. Because what 3I Atlas did after that wasn't just impossible, it was deliberate. When the first density maps came in, nobody wanted to believe them. NASA's models showed that 3I Atlas was far less dense than expected. Not a solid rock or ice cluster, but something hollow. That word alone sent a shiver through the entire astrophysics community. Because in space, hollow means engineered. Natural objects, asteroids, comets, even planetary fragments are messy, dense, chaotic. They don't form symmetrical cavities, and they certainly don't maintain uniform walls with precise thickness. Yet that's exactly what the simulations revealed. The object's outer layer, roughly 400 meters thick, surrounded an inner void, an empty chamber large enough to fit a small city. If these readings were accurate, then this wasn't a rock at all. It was a shell. NASA scientists called it the hollow hypothesis, and though it sounded absurd, the math refused to cooperate with skepticism. The radar signatures didn't just bounce off irregular terrain, they resonated, as if echoing through a metallic cavity. Even more puzzling, its rotation slowed down by exactly 0.07% after the internal density shift. That kind of precision doesn't happen by accident. So the question arose, was this hollowing a natural phenomenon or a controlled adaptation? Some theorized that 3I Atlas might be a fragment of an ancient megastructure, a piece of a Dyson-like construct that broke free from its parent system millions of years ago. Others went further. They suggested it could be a self-contained vessel designed to protect something or someone during an interstellar journey. Think about that for a second. An object from beyond our solar system, hollow, reactive, expanding, and now adjusting its spin to maintain balance. Nature is efficient, but it isn't meticulous. 3I Atlas was both, and then the data gave us one more reason to question everything. The hollow wasn't uniform. Certain parts expanded faster than others, as if guided by an internal blueprint. And that led to the most controversial claim yet, that what we were watching wasn't random transformation, but construction in progress. In the following weeks, telescopes from Chile's Very Large Telescope Array and NASA's Deep Space Infrared Observatory captured something breathtaking: patterns of light shifting across the surface of 3I Atlas like rippled code. The expansion wasn't chaotic. It followed distinct zones, bright, angular regions growing outward while others remained static, almost as if sections of the surface were being activated in a specific sequence. And when scientists mapped those zones in 3D, they saw geometry that nature doesn't use. Straight lines. Perfect hexagonal symmetry. Intersecting grids that echoed the precision of human engineering, only scaled up to astronomical proportions. The pattern looked like a tessellated framework, similar to heat-dissipating tiles on spacecraft hulls, but covering kilometers of surface. It wasn't just expanding, it was assembling. Infrared readings confirmed bursts of thermal activity, not explosions, not sublimation, but short, localized surges of heat, consistent with energy transfer. It was as if the object was recharging itself, section by section. NASA's internal term for this event was chilling, the awakening sequence. Meanwhile, independent observatories reported something else. Each time a new region of the structure lit up, its spin adjusted slightly, maintaining perfect stability despite its growing size. That level of control implies active feedback, the hallmark of intelligent design. For context, even our most advanced space telescopes drift by millimeters due to thermal expansion, yet this object, over hundreds of kilometers across, maintained microsecond rotational precision. That's not coincidence, that's coordination. By now, even the skeptics were silent. No natural comet behaves like this. No random body self-regulates its geometry in real time. So the question changed. It was no longer what is 3I Atlas, it became what is it preparing for? And as the structure completed its final visible phase of expansion, a new signal, faint but deliberate, emerged from the dark between the stars. What we detected next would shake even the most skeptical minds to their core. In science, when reality defies our understanding, we do what humans have always done. We build theories. By the time 3I Atlas finished its last expansion phase, three main hypotheses had emerged. Each one bold, each one incomplete. Theory 1, the natural mutation. This was the most conservative explanation. According to this model, 3I Atlas could be an exotic fragment of a tidal disruption event, a body torn apart near a dying star, compressed under immense magnetic fields, then expelled into interstellar space. Under this idea, the apparent expansion might be a delayed relaxation of material, a cosmic balloon returning to equilibrium after billions of years of stress. But there was a problem. The timing was too perfect. The expansion wasn't random or uniform, it was sequential, step by step, zone by zone. Nature doesn't move with such deliberate choreography. Theory 2, the autonomous probe. This one divided the scientific community. If 3I Atlas was hollow, self-regulating, and showing energy redistribution, could it be a form of machine intelligence, a self-repairing, interstellar probe, perhaps sent by a long-dead civilization? It's not as far-fetched as it sounds. In 1960, physicist Ronald Bracewell proposed the concept of Bracewell probes, self-replicating robotic messengers designed to explore the galaxy on behalf of their creators. Such probes wouldn't need to communicate instantly. They'd learn, evolve, and adapt, just like 3I Atlas appeared to be doing. And then came Theory 3, the hybrid anomaly, a radical middle ground between nature and technology. What if 3I Atlas began as something natural, a comet or asteroid, and somewhere in its journey encountered an artificial influence, an alien nanostructure, a dormant machine, or even a self-organizing pattern of quantum matter that merged with it? Over millions of years, that hybrid could have become what we now see, a symbiotic fusion of geology and engineering. Each theory carried profound implications. One rewrote physics, another rewrote history, and the third rewrote the boundary between life and machine. But even as the debate raged, one truth became impossible to ignore. Every day, 3I Atlas was behaving less like a rock and more like a blueprint. And if we wanted to understand it, we didn't have to look to aliens. We just had to look in the mirror. Here's where the story takes a sobering turn, because the more we studied 3I Atlas, the more it began to resemble us. Think about how humanity designs spacecraft. We build them modular, hollow, lightweight, with adaptive panels, radiators, and self-regulating spin to balance heat and momentum. The James Webb Space Telescope, for example, unfolded its massive golden mirrors in space like origami, layer by layer, guided by pre-programmed precision. Each deployment was timed, measured, and verified to within fractions of a degree. Now scale that idea up, not by meters, but by kilometers. Imagine a vessel built to assemble itself after traveling light years through interstellar dust. A machine that slumbers for millennia, awakens when it enters a new star system, and begins adapting to local conditions. Sound familiar? Because that's exactly what 3I Atlas appeared to be doing. Even its hollow core made sense through the lens of engineering. A hollow structure reduces mass, protects delicate systems, and provides room for payload, whether that's machinery, data, or life itself. Its reflective panels? Possibly solar collectors. Its thermal surges? Energy activation. Its precise spin control? Attitude stabilization. If humanity had discovered 3I Atlas in a laboratory, if it were sitting in orbit around Earth right now, we'd call it a ship. So maybe the question isn't whether it's natural or artificial, maybe it's why something like this exists in the first place. Is it a survivor, the last remnant of a civilization erased by time? A messenger, drifting endlessly until it's found by another mind? Or is it a warning, a silent monument left behind to say, we were here once too? Every line of data, every reflection curve, every pulse from this object leads to the same unsettling truth. Whatever 3I Atlas is, it's not just moving through space, it's remembering how to move. And that realization that something out there is reawakening set off the most ambitious investigation in NASA's modern history. Because the next discovery would suggest we're not just observing it, it might be observing us. Science is built on communication, peer review, open data, collaboration. But sometimes, silence says more than words ever could. In the days following the 3I Atlas expansion, the world expected NASA, the ESA, or at least one of the major observatories, to step forward with an explanation. Instead, nothing. No press conferences, no official models, just a handful of carefully worded statements buried deep in technical reports, vague phrases like unusual morphological evolution and ongoing analysis of volumetric data. That silence wasn't ordinary caution. It was the sound of institutions realizing they had run out of language. Inside the scientific community, leaks began to circulate. Astronomers whispering that their data was being held for verification. Research teams asked to delay publication until further modeling could be performed. Even the infrared telescope facility in Hawaii, quietly restricted its live data stream for the first time in over a decade. To the public, it looked like discipline, careful science. But behind the scenes, it was confusion. No one wanted to be the first to say, "This doesn't make sense." And maybe they were right to hesitate, because once you admit something breaks the rules of physics, you don't just rewrite textbooks, you rewrite reality itself. Yet silence breeds curiosity, and curiosity breeds questions that don't go away. If 3I Atlas had doubled in size, and that data was real, why was no one willing to discuss what it meant? Why were government agencies suddenly coordinating telescope schedules? Why did independent researchers find their remote access quietly restricted? Perhaps the institutions weren't hiding answers. Perhaps they simply didn't have any. In science, there's a rare and unsettling moment when discovery turns into disbelief, when even the experts must confront the possibility that the universe just changed the rules and no one knows why. That's where we stood in October 2025. Humanity had the data, the instruments, the eyes to see, but not yet the courage to speak. This wasn't the first time the universe sent us a riddle. 3I Atlas might be the loudest message, but it wasn't the first whisper. In 2017, we met ʻOumuamua, the first known interstellar object to pass through our solar system. It was small, fast, and strange, tumbling erratically, accelerating when it shouldn't have. Its surface reflected sunlight in ways that didn't fit any known asteroid model. We called it a rock, then a comet, then finally, something else. But by the time we turned our telescopes, it was already gone. Then came 2I Borisov in 2019, a comet that behaved perfectly, as if the cosmos wanted to reassure us. See? Not everything from the stars is strange. But that reassurance didn't last, because in 2025, 3I Atlas arrived, and suddenly, the pattern emerged. The first visitor broke our expectations. The second restored our comfort. The third shattered it completely. Look closely, and it feels deliberate, like a sequence. Test, confirm, reveal. ʻOumuamua taught us we weren't prepared to look. Borisov taught us what normal should look like. And 3I Atlas taught us that normal might no longer apply. If these were random objects, the odds of such progressive anomalies appearing in consecutive visits are astronomically small. Each one arrived a few years apart, each one displaying an escalation in complexity, in behavior, in intent. Could it be coincidence? Maybe. But if it isn't, then we're not just seeing visitors. We're seeing a pattern of contact. ʻOumuamua, the scout. Borisov, the control. 3I Atlas, the messenger. And the message that the void between the stars is not empty, that something or someone has been watching, measuring, preparing. Perhaps the universe has been trying to start a conversation, and only now in 2025 are we finally listening. The moment scientists dread and dream of, in equal measure, had arrived. The countdown to perihelion, the point where 3I Atlas would pass closest to the sun, had begun. 3 days, 72 hours. That's all the time left before humanity would know whether this mysterious object was natural or something far more profound. Every observatory, every telescope capable of tracking its path, was aimed at one point in the heavens. The James Webb, the Hubble, ground-based instruments from Hawaii to Chile, all locked on a target that refused to behave. But as 3I Atlas approached the sun, it didn't flare up like an icy comet should. It didn't disintegrate or brighten from solar heat. Instead, its brightness stabilized, almost as if something inside it was adjusting, correcting, preparing. And when it reached its closest point, for just 18 minutes, 3I Atlas emitted a narrowband radio signal. Faint, deliberate, repeating every 4.2 seconds. It wasn't noise, it was structure. No one could explain it. No one wanted to. But the universe had just whispered again. And this time, it felt like it was whispering back. When we look into the universe, we assume we are the observers. We point our lenses outward, confident that we're the curious species trying to understand what's out there. But what if, this time, we are the ones being observed? Every data stream, every signal, every unexplained fluctuation seemed to trace back to one haunting idea. 3I Atlas was not just passing through, it was looking, maybe scanning, maybe studying, maybe remembering. If that's true, then this encounter is not just about discovery, it's about perspective. Because for the first time in human history, the sky might be holding up a mirror, and in that reflection, we might not like what we see. Our civilization has only existed for a blink of cosmic time. Yet here we are, facing something ancient, something possibly intelligent that doesn't act like it's new to the neighborhood. Maybe it's been here before, maybe we were never alone, and maybe the ones who left it behind have always been watching. There comes a moment when science and wonder collide, when the data stops being numbers and starts feeling like a message. 3I Atlas brought us to that edge. For some, it was proof of a natural phenomenon beyond our current understanding. For others, a whisper from an intelligence older than our sun. But whatever it was, it forced humanity to confront a truth we often avoid. Our universe is not obligated to make sense to us. It just is. And every so often, it throws us a puzzle not to solve, but to humble us. When the light of 3I Atlas finally faded, so did the chatter. No official statement, no conclusion, just silence, and a sky that suddenly felt more alive than ever before. Neil's voice would close with quiet awe. Maybe it was a rock, maybe it was a message, but either way, it reminded us how small we are and how infinite our questions still remain. When you stare into the night sky, you're not just looking at stars, you're looking into time itself. Every photon that reaches your eye is a messenger, carrying the story of something that happened millions, sometimes billions of years ago. But 3I Atlas was different. It wasn't just a story from the past. It was a question from the present. Its strange acceleration, its hollow echo, its fleeting signal, all of it seemed to ask, are you ready to see beyond what you think you know? And maybe, just maybe, the universe isn't a cold, empty void at all. Maybe it's aware, not in a way we understand, but in a way that reminds us that observation goes both ways. Perhaps we are not the center of cosmic attention, but a small part of something vast, interconnected and alive. Because if 3I Atlas was a message, it wasn't just from somewhere else. It was also for us, a reminder that every discovery changes, not just what we know, but who we are. Neil would pause here, soft, thoughtful, and say, when you look up tonight, don't just ask what's out there, ask who might be looking back. The universe doesn't wait for permission to surprise us. It doesn't care about our boundaries, our doubts, or our fear of the unknown. It simply exists, mysterious, magnificent, and endlessly curious. But curiosity is our greatest gift. It's what makes us explorers. It's what brought us from cave fires to telescopes, from myths to mathematics, from wondering to knowing. 3I Atlas reminded us that the cosmos is still full of questions waiting to be asked and answers waiting to be found. And that journey begins with people who choose to keep looking. So to everyone watching this, don't let the mystery end here. Keep questioning, keep imagining, keep watching the skies, because the moment we stop exploring is the moment the universe stops speaking. The universe is vast. The truth is out there, and our story is only just beginning. If you felt that spark of wonder, don't let it fade. Hit subscribe, turn on notifications, and join us as we decode the next great mystery written in the stars. This is Nova Atlas, where the universe finally speaks and we listen.